The continental drift theory was proposed by German geophysicist Alfred Wegener in 1912. It suggests that the continents were once joined together in a supercontinent called Pangaea, and over time, they have drifted apart to their current positions on the Earth's surface. Evidences supporting continental drift theory. 1. Fit of the continents. The coastlines of Africa and South America seem to fit together like puzzle pieces. 1. Similarly, the coastlines of other continents also appear to fit together. 2. Fossil evidence. Fossils of the same species are found on opposite sides of the Atlantic Ocean, which suggests that these continents were once connected. 3. Rock formations. The rocks on either side of the Atlantic Ocean match in age, type, and structure. 4. Paleoclimatic evidence. The distribution of glaciers and ice sheets during the past supports the idea that the continents were once in different positions than they are today. Criticism of continental drift theory. 1. Lack of a mechanism. Wegener couldn't explain how the continents moved, and his theory was criticized for lacking a plausible mechanism. 2. Limited evidence. At the time the theory was proposed, the available evidence was limited, and many scientists found it difficult to accept that the continents could move. 3. No seafloor spreading. The discovery of seafloor spreading in the mid-20th century showed that the oceanic crust was constantly being formed and destroyed, which could explain how the continents moved. 4. Scientific community opposition. The scientific community initially rejected Wegener's theory because it did not fit the established geological paradigm of the time, which led to his theory being largely ignored until later. In conclusion, although the continental drift theory faced criticism and opposition, further research and discoveries have confirmed the theory's accuracy. Today, the theory is widely accepted, and its significance is evident in the understanding of the Earth's geological history and the ongoing changes to our planet. Seafloor spread theory. The seafloor spreading theory was proposed in the 1960s by Harry Hess, a geologist and naval officer. This theory explains how new oceanic crust is formed at mid-ocean ridges and how it moves away from these ridges, creating new seafloor. Here's how the seafloor spreading theory works. 1. Mid-ocean ridges. Mid-ocean ridges are underwater mountain ranges that run through the Earth's oceans. 1. These ridges are formed by the separation of tectonic plates. 2. Plate tectonics. The Earth's surface is made up of several large plates that move slowly over time. 2. Where these plates meet, there are often earthquakes, volcanoes, and mountain ranges. 3. New oceanic crust formation. At mid-ocean ridges, magma rises up from the mantle and solidifies to form new oceanic crust. 3. This process is called seafloor spreading. 4. Movement of oceanic crust. As new oceanic crust is formed at the mid-ocean ridges, it moves away from the ridge and towards the edges of the tectonic plates. 4. This is due to the convection currents in the mantle which push the plates apart. 5. Subduction. When oceanic crust meets continental crust or another plate, the denser oceanic crust sinks below the less dense crust, creating a subduction zone. 5. Here, the oceanic crust is destroyed by being melted back into the mantle, and this completes the cycle. Evidence supporting seafloor spreading theory. 1. Magnetic stripes. The rocks on the ocean floor have magnetic properties that record the direction and strength of the Earth's magnetic field at the time they were formed. 1. These magnetic stripes are parallel to the mid-ocean ridges and show that the seafloor is spreading. 2. Age of oceanic crust. The age of the oceanic crust increases with distance from the mid-ocean ridges, supporting the idea that new crust is being formed at the ridges and moving away from them. 3. Earthquake and volcanic activity. Earthquakes and volcanic activity are concentrated along the mid-ocean ridges and subduction zones, providing evidence of the movement of tectonic plates. In conclusion, the seafloor spreading theory provides a comprehensive explanation for the creation and movement of oceanic crust. This theory is widely accepted by the scientific community and has helped to advance our understanding of plate tectonics and the Earth's geologic history.